fact, actually sets the tone for our next panel discussion, which is about integrating technologies for plant maintenance. So it actually makes sense in listening and experiencing your presentation. So please stay with us because you are also part of this panel discussion. And let me introduce our other esteemed panelists here. I will start with Dr. S. Devarajan, Senior Vice President, TVS Motor Company, winner of the prestigious Rolls-Royce Award for Excellence in Manufacturing Concepts and Implementation in the UK. He has been working with the TVS Group for the last 38 years. During this time, he has been involved in many projects, including setting up facilities of press shop, welding shop, painting plants, heat treatment plant, machining of steel and aluminum engine parts, as well as assembly lines. Presently, he is the head of production engineering and new technology in the organization. Please welcome him aboard. Thank you so much, Dr. Devarajan, for joining us.
Thank you very much. Thank you.
The next speaker is Mr. Lakshmi Narayanan Govindrajan, CITO, Head Business Excellence and Asset Integrity with Vedanta Resources Limited. With 18 years of experience in different functions like operational excellence, quality innovation, and asset optimization, as well as digital transformation, he has also won several awards and accolades across various manufacturing sectors. Highly energetic and result-oriented about exploring new ways of doing things by constantly innovating and converting new learnings to action. He enjoys the journey of transformation of culture as well as workplace. Very interesting profile. Thank you so much for joining with us today.
Thank you.
And I move on to our next speaker, who is Mr. Brijesh Kumar Verma, Digital Transformation Leader with Volvo Eicher Commercial Vehicles, an industry leader with more than 16 years of professional experience. He is currently heading the digital transformation practices at Volvo Eicher Commercial Vehicles. He has been accomplishing the value outcomes of large-scale digital transformation programs and comes with a very strong industry background as well as domain knowledge of manufacturing enterprises. Thank you so much for joining us, Brijesh. We also had another speaker, Mr. V. Venkat Narayanan from Dr. Reddy's Laboratories. Unfortunately, due to certain emergency, he has not been able to join us today. So I will immediately move on to our esteemed moderator, that is Mr. Ashok Muthuswamy, Vice President, TQM and Business Excellence with Tractors and Farm Equipment, that is TAFE, with 3 decades of extensive experience in manufacturing, operations, Lean Sigma, supply chain management, quality, and project management. He has turned around businesses and implemented strategic improvements, positively impacting the bottom lines of various organizations. In his current role as the Vice President of TQM and BE at TAFE, he is responsible for the continuous improvement across multiple plants, products, as well as processes. Thank you so much for joining us, Mr. Muthuswamy. It is a pleasure and privilege to have you with us. And now with that, I hand over the session to you. Please take it over from here. Thank you so much.
Wonderful. Thank you so much. And I am so glad to moderate this session with all the august panelists. So with that, I was also fortunate to listen to the previous presentation also. And some snippets which I gather, which we all know is how these digital interventions have been transforming conventional industries. But I can go, there are numerous examples, like, how you take a 100-year-old industry, typically chemical industry or for that matter, cement industry. And how do you get that into a digital, in a digital environment, industry 4.0 digital twin? Those are extremely interesting topics. Very, very pertinent and do add tangible benefits to businesses. So with that, let me request my panelists. Maybe I will start with Dr. Devarajan. So Dr. Devarajan, maybe you can give us an idea about what are the new digital interventions in plant maintenance, whether it's managing assets, ensuring safety, or monitoring through remote. So what are out there, Dr. Devarajan, and what is it that you have used in TVS? Maybe if you could give us an outline, that would be wonderful.
Well, thank you very much, and thank you for Pro Media for this. See, basically what's happening in automobile industry is we are trying to see how to get the highest level of customer satisfaction, business growth and profitability. We are trying to capture all the data through sensorization, bringing the real data transparency. Finally, in terms of manufacturing, how to improve the OEE is a key area. The OEE has availability, output performance, quality performance, and majority of time, availability of assets is a key area. Downtime, regular downtime is there, but unplanned downtime, how to capture. We have got, our industry is quite old and we have got both legacy machine and the new machines. So first thing is to ensure that how to get data from the system. So we have tried to use many sensors from the old machines. We started using the hand-on lights as a part of initial area to say whether the machine is running or not running, capturing the data through a system and putting on the dashboard. So it is not straight away putting all the sensors. We went from the basics of putting the data acquisition system, going by the hand-on lights, taking the data. The next step is we went further. Say, okay, our OES has to be improved, but it is not enough to say whether the machine is running. How well the health of the machine is there, how well the spindle temperature, the bearing, slides. We started using the FANUC MTI and trying to put the sensors into spindles, slides, and into the old machines and the new machines. One thing is every asset has a cost. Every asset has got a risk, cost, and definitely performance. How to interact risk, cost, and performance. So can we identify the problem before it occurs? For example, temperature, vibration. For different systems, different sensors are used. For example, conveyor. How to get the continuous current in the conveyor. How to have the details into the bearing failure in the conveyor. Winding areas, cable loose connections, gearbox overload. We are trying to go into elements of the machines, elements of the system, oil seal failure, for example, or the stack conveyor, the chain tension, temperature sensing. Bearing failure, we're trying to use VFC, rolling out in terms of, and the PCB failures. And in terms of CNC, the system fan condition, system battery condition, in terms of servo spindle override of the feed, motor current, motor temperature. So it is not that we are trying to put sensor, but effective area, coolant, for example, coolant, hydraulics, lubrication, oil pressure, oil temperature. And we're trying to bring it in the front of the machine itself to say, before the problem occurs, can you take action? For example, robo. We're trying to use the pump rotor, torque, axis motor torque, pressure. So what's happening is we are going to detail of the elements because our industry is quite a continuous industry. Every 20 seconds, we need to put a vehicle out. So we can't have stoppages of any account at all. We need to take action beforehand. We are trying to use many of the CBM, like what I mentioned, IoT in the assembly line, machine shop, sensors, vibration sensors, voltage sensors. And of course, in the last session, we're talking about AR, VR, bring the digital class, remote feedback, and then taking action in terms of the paint plants, in terms of the exhaust, in terms of the paint plant information. So it is end-to-end in terms of sensorization, data capturing. We have also partnered with many people like Predictronics, Untitled Chapter, FANUC, because what's happening is old machines, new technology machines. So we may have to have a combination. One more thing I found out in all this maintenance is a combined effect. It cannot be given to only one supplier. I mean, it has to be joined with our team, with our maintenance team, with the operations team. And finally, how to get quick feedback, how to get the uptime. We always call it QCT, quality, cost, time for implementation, time for decision taking. So it's a continuous journey, and we have extended to energy conservation, putting the meters in the flow diagram, in terms of the power, in terms of the water, in terms of the recycling of the plants. So it is not only the maintenance of the machine, any machine which can give you output, where we can capture the OEE, where we can capture the data is most important in IT. So that's the area where we have gone into every step, and what's happening is a continuous journey. It is not like only once you do, it's a continuous journey of the maintenance. and how to get the benefit for the customer from the quality angle, from this thing. I'll talk about this further when the discussion comes. But basically, we've gone into every element of machines, every element of assembly line, machine shop, assembly line, welding line, capturing the data, having the visibility to the operator. Any problem, it goes back into the maintenance team to support. It's a joint effort in many of these areas and going to the actionable areas of maintenance. So it's a journey, and it's a very, very interesting journey. We can't say we can put only the new machine. Because our machine is old. We have to go with old machines. We have to ensure that we get data from every element, including the pump, including the water pump in my maintenance area, where to know whether it's working, whether it's giving the output what is required, and take action. So this is an area where it is an end-to-end which gives you benefit, and you have extended to the JIT lines. We have extended to the supplier lines. We are extended to the community. So I'll talk to you a bit later on this.
Wonderful, Dr. Devarajan. Some of the aspects that you mentioned are extremely, pertinent and also resonated with me. One of the things that you mentioned is about risk, cost, and performance. Yeah. Unfortunately, the cost is going down, and eventually it might not even be a factor. Like 20 years ago, this whole predictive maintenance is an extremely serious effort with all the sensors, which are expensive. They have to be hardwired, and so on and so forth. Nowadays, with all the sensors getting extremely cheap, no wiring is needed. All these things are like IoT and cloud-based, and I do recall rolling out one initiative 20 years ago. It's something which I rolled out like 6 months ago, and oceans of difference in terms of performance as well as cost. So it's an extremely exciting time to be in the space. And I'll come back to you. I've got the other panelists, but one aspect which I like is you mentioned about going back always to the basics, whether it's TQM or and ensuring the basics before we get into all these digital stuff, because you don't want to digitalize, which is not optimized. That is a very interesting topic, but I'll come back to you at the end of this discussion. So my next question would be to Lakshmi Narayanan. Maybe Lakshmi, if you could elaborate. What are the IoT technologies for remote monitoring and diagnostics? What is around, and what are the new developments in this space, Lakshmi?
If you can see me in the new developments which is already happening compared to India with other countries, I'm seeing that close to around 60% we are going in digitalized in the present scenario, comparing to America or Europe, which PwC has resulted in the recent past. And I'm finding that the changes is going faster, and there are a lot of new entrants are coming there from different other countries to India, and they are investing with us. And I'm seeing that there are a lot of startup companies are also growing in the recent past in the digital era. And we found in Vedanta also, we used to have a Vedanta Spark program where we have close to around 1,000 startup companies we have listed up. And from there, 300 companies we have been just started working with them. And some of the companies who have been directly approaching us, and then we have some kind of a tie-ups, and we gave the problems to them how to resolve these issues. It is not only a technology driven, and we gave the problem straight away. So this is my problem. Can you please help us the digital solution, and how I can able to how you and me can able to work together, and we invest them back also. So it's not meaning that we will just give you a hand once we see the results is coming out, and we invest them back. And there are new technologies also which we introduced, like there's a new company which has been took over at Bokaro Steel, where I'm working presently. I'm also data scientist. So what I've done is there are a lot of drones which we have been bought in there, because we spent a lot of crores of rupees in doing this surveying these kinds of mines where there are a lot of materials has been stored in terms of raw materials. So these are been manned by different people. So what we have done is we have used drones not only just for only the survey purpose, and also we have understood that what is the volumetric analysis can be taken out, what is the volume which has been present over there, when the volume can be consumed, what is the time taken, and it helps in different types of planning as well. And we have the SAP HANA has been recently implemented, and then we have the IoT devices which has been connected through that, and we are taking out those kind of information through that, and then we are getting it done. So there are new technologies which are keep on developing, and if you can see, particularly say example, if you take some drones also, drones is used in many applications, even in mining, even in the confined spaces also, even in boilers inspection. Inside, it takes huge amount of time for anyone to go and inspect. So even there are some caged drones are also available today in the market, which can be used, and many companies are using, and we also tried it. And even we have a lot of tube leakages are also happening in one of our boiler plants, and we have some kind of a digital solutions over there, and then we have also implemented it. So it's a matter of, like as you rightly said, there are some old thoughts are also sitting there, and there is a new people are also sitting over there, and how you merge it. There are some operators who are sitting, who has done physically there, and how you wanted to bring that change. That is very, very key challenge, which is already there in our hand. So we know that digital is going to help us. And the way that we have been taking there to the plant, and the way that we are going to implement it, that is going to bring the change. So if we have a collaborative way, we have a lot of sensors in even in our drive systems. We have some NASA approved sensors we have bought, and there is a startup company who have been working with us, and we got a real-time sensors, and we also have a predictive analytics in our hand actually, and not only to me and my HODs, it should be there with the operator who is supposed to be using. So we have given it to the operators, but the challenge which you are facing right now is basically the operators are not taking on time, and they have old systems which is there in that plant, and you have some safety issues will be there if you give some kind of a mobile phones which you have been giving, that he will be playing with the mobiles. So there are some kind of challenges is there still, but I can say that 80-90% of the time we are able to make it success in those areas, and we see there is a result is coming out. It is only a transformation of a mindset of a guy who is sitting on the ground to get changed. So that is the only challenge which we have been facing presently. But there are a lot of new technologies we got implemented and we have adopted, and the usage of this data is very, very key. Going further, we have done many number of Six Sigma projects or whatever projects we used to see, and everything is now available as open source, and it is ready-made available there with an automated machine learning algorithms with random forest or decision trees. Many algorithms we use today and get the predictive health of the equipment. So we have done that one, and we have tried with many of the sensors also, and I have saved many return on investment back to the organizations also. There are a lot of key successes also happened along with it. So our intention is very, very important, is what we wanted to do, and where we wanted to use this kind of technologies, and where we wanted to engage the startup companies. So that strategy should be very, very clear. We have a clear roadmap of the IoT 4.0. Sometimes what happens is, there are one sensors when you bought in as for a particular application, it can be used in many other locations also. You cannot keep the drones idle. You can use the drones in some other locations for different other purposes. So, like for maintenance, we use drones actually. In some of the pipelines, we go and inspect. In oil and gas also we used to do. Even in some of the areas we do peripheral, even the security used to do a peripheral stock, where we deploy a lot of security guards in those locations. During patrolling. So many applications can be used. So there are two ways of looking at. One is from the digital perspective of take any one of the tool, how it can be applied. That is one way. Second is, what is the problem you are facing, how this can be given it into the hand. Like I have used one of the recent tool, I don't have drawings. This plant has been to core, and we found most of the drawings are not available. And you cannot go there and measure everything in a digital solution is required. So I searched some kind of digital solutions. I am getting some 1 or 2% error is coming there still, but I'm able to make it up. I'm able to make it up. The same thing when I captured for that drawing making. What I've done is I have done into a kind of a training program also. So that's been converted into a kind of a training program, and the entire tanks, how it should be used, so can be used into a AR VR version, and then where you can convert these kind of technologies into a practical job. So this has been done evidently in many of the organizations today is now going on. The only thing is the adaptation at the ground level and the strengthening them on the ground level is very, very key for our stress.
Also like to add is this IoT gives us a tremendous chance to catch up. So now the whole playing field is kind of reset with the other, let's say, for lack of a better word, other advanced geographies. With the IoT, we can leap forward in terms of putting robust processes, because your processes, the dependence on people can be reduced. And you can also de-skill operations in the sense you don't need to have that extremely talented resources. You can figure out how these digital interventions can augment or relieve you of certain dependencies or ensure robust processes. See, for example, I know some large salt fields with 30,000-40,000 hectares of salt field, which had a challenge of operating various pumps. They've used this IoT, satellite, drones, everything to understand the various Bomi levels of salt and operate things accordingly. So these are excellent tools. I think we can talk all day about it, but for lack of time, let me move on to this question to Krunal about how do you deploy VR and AR technologies to improve asset life and also certainly improve our safety of our personnel first, and then how do we improve the safety of the assets? Yeah, maybe over to you, Krunal.
Thanks. Thank you, Ashok, and thank you, everyone. Very happy to be part of this esteemed panel. The topic is, if you look at all of you are expert in your domain. I don't need to stress it more, but from the outside in approach, right from the planning stage, when you are doing a factory planning, and now we call it as a smart factory planning or a digital factory planning, to plant design improvements, operations, quality checks, maintenance, and all the other allied offices like warehouses or logistics and so on and so forth. Safety, productivity, and quality have been very important. So far, what was happening is that we used to plan certain things on the operational technology systems, and the execution used to happen like, the last mile execution was always manual. And then we said that, okay, we convert that into digital by collecting data. So we started putting IoT sensors, and we started making smart devices to get the next phase of automation, where we said, okay, how do we execute the last mile and start collecting the data? Then now what we are talking is that, okay, we have smart devices now. How do we make our resources smart, our people smart, and how do we ensure that they are taking the right steps and taking it in the right manner? Like, for example, if we look at a large automobile company in Europe, they use our technology basically to create 3D models of their parts. And that is used for training their employees on even without getting onto the floor. So that actually relates to productivity, safety, quality, and everything, because now you are using virtual simulators with a TeamViewer AR or 3D VR to ensuring that your employees are properly trained and they can then do their job well. Next is basically when the work is going on, the people require guidance, manual or a physical manual for doing the guidance. And we have seen that when we digitize this manual and give it as a workflow onto a smart wearable using the TeamViewer AR platform, efficiencies have increased drastically, because one is up when it is available. Two, it is complete hands-free, and a person ergonomically can achieve much more than he would otherwise do it using a physical manual. Third is expert on demand. See what I see. There have been, not that we already spoke about the skill gap and doing work with less skilled employees. So how do we ensure that the help is available when it is required? So using AR, VR, we are seeing that a very regular use case, not only internal to the factory operations or plant operations, but also to external customer support. We have a very large automobile company, like I can name that, it is Ford Motor Company, who is rolling out See What I See use case on TeamViewer, primarily to support their front-end mechanics and the front-end engineers to fix the level 2 or level 3 issues with the car, and so on and so forth. This is just an example. Finally, on the warehouse operations, so helping the logistics employee to find what to pick from where, to sort the things in the right manner, and that actually improves the whole warehouse efficiency. Now, the crux of this matter, or the summary of this entire automation, would be how do we use human intelligence at the same time, create that into a process, so that we all have experienced this in the past. If the warehouse store manager is absent today, then probably the replenishment level will drop drastically. If the lineman is not available in telecom, probably a lot of calls in that area would not be attended, because just that he knows the network very well and no one knows the network, and so on and so forth. So how do we take this human intelligence and put it into a process, and then feed it back to the IT and OT systems, so that we can have advanced or smart decision making? And that's how AR VR has become a very renowned technology. And what has happened in last 3 years, Ashok, is the devices have come up. We have now devices which are reasonably in price, as you said, cost. Network has improved, so we are seeing even adoptions of these solutions in remote places. And moreover, the software sophistication has also improved. So like if you look at TeamViewer software today, we operate on 3G, mobile hotspot. You don't need a very hi-fi bandwidth or a dedicated a leased line for delivering this solution. The solutions are working on normal internet, and they are secure enough for data transfer or for any other operations. So with the advent of all this, and with the fact that people are conscious about safety, conscious about quality, and conscious about process-driven operations rather than people-driven operations, AR VR is going to add a lot of value to next phase of automation.
Mm-hmm. Wonderful, Kunal. Yeah. I think you touched on few important aspects, especially in the end. What you said is improvement in connectivity, improvement in analytics, more and more with the deep learning, AI, ML, all that stuff. These all can be leveraged to put in extremely robust processes, which will be impossible just with human knowledge alone. Of course, human knowledge is the beginning of all these things. But with the advent of all these tools, if they are well leveraged, you can put absolutely world-class operations and run that with available skills, even if you don't get the top skills, so the whole point is, see, you have a lot of people, which is existing. A lot of people are available for employment with limited skills, and now if you could do that, you can tap into this huge pool of people. It will be beneficial for businesses, and it will certainly be beneficial for the individuals, and I think that will be a win-win. So good, Kunal.
And but one more example, Ashok, which I would like to cite here is probably in the tractor manufacturing industry, like where you come from. Ubimax, which is the company which we acquired, worked very closely with John Deere to basically do smart manufacturing. So what is happening is, in assembly lines, a lot of things are automated, but there are still a lot of parts which are human assembled. And if there is a delay in that particular small process, and Bridges also would understand that from the industry standpoint, it will add up to the delay in the overall turnaround time of the assembly. So if we are able to make that solution available, where we can have a guided manufacturing procedure for that floor engineer, who is while doing repeated job, his error rate can be reduced. Probably that will put a huge improvement in the overall turnaround time of the assembly. So we are seeing not only in safety, but also in operations, a lot of AR use cases which are relevant.
Understood, Kunal. In fact, you touched upon when you brought out tractor. In TAFE, also going back to Dr. Devarajan's point, what we did is we digitalize a whole lot of TQM aspects. So I would rather call it like a TQM next gen, where we talk about POKs, and also Dr. Dev touched upon Endon. What we did is we digitalized all these aspects, so that if a particular component has not been put into the assembly line, the tool on the next station will not work because these are all linked in our MES and other instrumentation system. We call it PID loops in the instrumentation, all these things. So again, going back to my point, you are not just dependent only on diligent operators, but you have these interventions which will not allow you to make a defective part. So that's how you get the biggest bang for these assets. And TAFE has been a forerunner in these areas, with our quality levels and performance levels, which is significantly high. With that, I will move to Brijesh for the next question. Brijesh, how do we move from predictive to prescriptive maintenance using real-time analytics? And before you answer the question, maybe because there may be people who would like to get a little bit more information. What is predictive? What is predictive maintenance and what is prescriptive maintenance? What is the difference? And how do we move from this one to that one? Over to you, Brijesh.
Thanks, first of all, to all of the members and Pro Manufacturing panel for getting me here. So, very interesting question, and it's very exciting, buzzword into a tech world in terms of how to move the current state of your, any of the process from prescriptive, from predictive to the prescriptive model. So generally a very short and crisp difference that how do we differentiate between the predictive and prescriptive. Predictive is somehow when the machine or the process is giving you an insight that what gone wrong, basically, what has gone wrong. And prescriptive is a stage where we can, get some insight that what needs to be done to, prevent that, basically. So it is a next level of insight generation, and also what if capabilities around generating that what needs to be done if this defects would have occurred, So generating the capabilities from the machines or from any of the processes around getting it the capability to give the answers that what needs to be done is, we call it as the maturity state of prescriptive analysis. So largely the data whole set plays a vital crucial role in this whole transformation journey. And now earlier, when a decade back, when we see that machines were not too intelligent and we are not getting the too much of data insights from the machine, the leading stage of any organization would have stopped till the predictive stage. But now the machines are generating so much of data which can be harnessed in terms to get the insight and the permutation combination, and also the business rule book engines around it. So let's say if we are having some threshold of our machines where we have set some temperature from this range to this range. If it goes beyond it, it gives an insight that the machine is on a probability of a failure. But what if the capability it can propose to those insight that whether you have to alarm down the temperature, whether you have to reduce your input numbers to the machine, and so likewise. Putting the prescriptive in place required a lot of business insight and business essence to leverage the prescriptive stage, basically. So in my opinion, I would say that tech is there, technology is not a limitation, but altogether it requires a different mindset. The way the other panelists would have also spoken about it, like Lakshmi and Devarajan, and you as well, and Mr. Kunal. So it's a set of a mindset that how we would like to solve the problem. So what is the problem and what could be the nature of the answers around it? That setups the basic fundamentals for the prescriptive maintenance around any enterprise side of organization. And it also depends upon kind of a complexity of an operation, complexity of machine, complexity of skill required at that point of moment. That is the basic essence we need to underline. And what is the criticality of those resources should be a prime factor while carving out your prescriptive digital journey for the plant maintenance. So that's my view in terms of how I translate and see this whole prescriptive journey for any organization.
Thanks, Brijesh. Yeah, in fact, I would like to add also going beyond maintenance, this prescriptive. I mean, in maintenance, you use the parlance prescriptive. In operations, you use advisory. See, with all these advent of all these digital capabilities, you move away from causation and you get into correlation. See, you have very rich data, not only based on one factory, but or one set of operations, but all the happenings throughout the world. You get the rich data, keep on analyzing, get more and more insights, and ability to come up with advisory is much higher. And with that big data, the correlation sometimes is brilliant compared to causation, which is based on a person's knowledge. Not that I want to overrule causation, but correlation is, it is relatively easier. And most of the time, it is even more accurate, unfortunately or unfortunately. So with that, I would move to Dr. Devarajan. One point that you touched upon, Dr. Devarajan, about endons and how you still go back to basics. My question to you would be, what I would always like to say that TQM will continue to be relevant. So, in your view, what is that the digital interventions? How is it supporting the cause of TQM, or rather the other way also, like how TQM is supporting digital? So, what is the synergy between these two animals, and based on your experience, Dr.
Excellent. I think it's a very, very interesting question. In fact, TVS is a strong TQM company. But basically, TQM has a big umbrella. It has got TPM, it has got lean into the umbrella. Because what we are doing is for the customer in terms of the quality level, in terms of the consistency of output. So it is very important that it's a combination of all these things which gives you TPM and TQM. So what we have done in our areas are, like what I mentioned earlier, is put a lot of processes into the system so that the quality is built at the source, whether the component source, the supplier end, or component source at each station, or even the machine area, how it is getting into this picture. So it is one thing is we have to, like what the business objective, the customer objective is very important for us to understand. In all these techniques, we have a lot of IoTs coming to the picture, but unless it is related back into business objective, others related back into the quality aspect. Quality means including the quality of the output, quality of the person, quality of the capability of the people. It's a combination of this. So in that context, all these digital tools will help in TQM. It's a main thing which are trying to work on. How? Because when you're talking about TPM in terms of the requirement of the people, it is a combination of all these things, the 7M conditions, whether material, method, machine equipment, material handling, sustainability, Mother Earth, all these things are related to give you TQM. All these aspects, like other panelists mentioned, TeamViewer mentioned, that everywhere you can have a seamless integration of all the things to give you results at each stage. At each stage of the project, for example, alpha, beta, QP, and with a legacy machine, with a new machine, capturing all this data. So maintenance is a very important, especially for the health of the machine, remaining useful life of the bearings, for example, mean time to repair and mean time to failure, competency building of the people. All these things are quality. All these things are total quality management. So, and predictive analysis for the speed of decision making for the business. So we have to take all the sensors, all the systems into place to give us business results, to give us quality results, to give us competency. Second thing is, India is going through a huge change. A lot of things are changing in terms of EV vehicles coming in terms of everyone is related. I should know from my mobile phone what's happening to my vehicle. So it is going such a fast pace. We have to link towards the business. Okay, and we have to link with the connectivity. So I think it's going to be huge in the next 1 year, in the next 2 years. All these things will become seamless like what we have on the cell phone. So finally back, it aids TQM. All these things is under umbrella of TQM, I can understand. And all the things are related from the business angle, from the quality angle. That's why I look at a combination of these things. Let's not look into isolation. Everything should result back into business. Everything should result back into quality. To the customer, finally. We are here for the customer. Secondly, one more thing I found is the final customer is a customer, person who buys a vehicle. But a first customer is an operator. How are we helping our facilities to talk to each other? How to ensure the consistency of output? So I'm going from the basics to the business and the growth, but let's not forget the basics. So that's why I say TQM is an umbrella where everything is related to each other. Secondly, one more thing I found out in many areas, according to what we have done, every element, including the water treatment plant, including the solar energy, what we are using, including the canteen areas in which solar is used, water purification. It's all a combination which can give you the business growth, the quality improvement, and that is TQM. So that's the way we have to look at the overall look at it, look at the future. And secondly, one more thing, we should be abreast of what's happening in technology. Huge one end, the technology is going up in a fast pace, industry is going in a fast pace. How we are able to get together, going into the basics, that is TQM. Going into people competency, going to people of element of machine. I feel it's a journey of both the best of both in terms of technology. Finally, it has to give it business result, and that's the way I look at it. And somehow I'm very much keen on making into a in TVS we always make into a system. We have correlation between the managing point, the checkpoints, and the KPI, KMI activity. Go into every element of work. It cannot give you result just by putting a software or just putting a tool. You have to get the basics from the elements, action taken consideration, analytics of it, get the business result of it, and look at the overall for the competence level. That's the way I look at it. I hope I made a point.
Right, Dr. Dev. In fact, based on even my own experiences, a lot of TQM concepts, if you digitalize, you are just putting, it's amazing synergy that you get. For example, you touched upon an MPCP, which is DWM. If you could automate this whole DWM instead of having it in spreadsheets, if you could capture the performances from the system, if these MPCPs are automatically populated, triggers are sent for reviews. No, that's how you take this concept, but you digitalize. That means you're putting it on steroids, and you get extremely significant benefits. So these are some of the aspects which resonated with me, based on also what I did earlier. One thing I really like to touch upon is these things never go out of fashion, whether it's Six Sigma, TPM, TQM. Yeah. In fact, once when we were working on particular boiler analytics, first we tried to understand the causation through regression tools and clustering tools. And then we went on to dynamic SOPs and digitalization. So you don't ignore the basics, always leverage, ensure the basics are there, and then go for digitalization. That would be my view. With that, I would ask one more question to Krunal about what are your experiences, Krunal, in terms of productivity improvement or flexibility improvement? What is the data point that you can share? Like it goes 1x, 2x, 1.5x, 10x. I know it's kind of a very open question. The answer will be typically it depends on the situation. But what has been your experiences on this?
So Ashok, we all of us have experienced this. We have been experiencing it multiple times because we speak to multiple customers, and you all have your experiences within your industries and your companies. But if you look at the entire digital transformation happening towards the operational technology, we see that the first challenge which we wanted to address was data, and that's where we started innovating and putting sensors and started collecting the data. The second challenge which we wanted to address was how do we use that data? And that's where analytics came into play, and advanced data science, AI, ML, maybe predictive or prescriptive maintenance came along. What we are seeing is the third phase where we say that, okay, human is in center of all this. The person who is executing the job, if he is not equipped properly, or if he is not getting the support what he has to do, or even forget that, if he is not given the guidance what he has to do, then probably that could be a point of failure for the entire productivity process of the whole plant. And that's where enterprises are now evaluating that how do I empower my this frontline worker, and empowering this with information, with actions, and with support is what we are seeing as the next phase. Now, when you put all this together, I'm not saying that one or the other will solve the productivity puzzle, but when you put all this together, like, you have automated smart devices collecting the data, you have good analytic systems to take, which can help you in your decision making. And then you have your people who are doing the action connected as well at the point where the data is collected or where the action is happening. And then all this is reported properly. We have seen a drastic improvement in productivity up to 40%. Sir, it could be in the whole process or as a part of the process, but there is significant improvement in process. Like, for example, if I take fixing a particular assembly, like it could be an electrical box, or it could be an electronic machinery of a helicopter, or a micro assembly of a car. We have seen anything between 25 to 40% improvement in the productivity of that person. Not only that, it is also, there are other KPIs which companies are monitoring, like the error rate. There are also soft KPIs like the employee satisfaction, improvement in the skill. And all this put together, can we create a knowledge organization? Which means that, if there is a breakdown which happens, and if there is an episode which was created around that breakdown, and the remote support was provided by an expert remotely from maybe Germany or from any international plant, and we record that and keep it with us, can that episode be for future reference a knowledge repository? So moving from data collection to data analytics to appropriate action, and keeping the person in center of all this, and then creating a knowledge organization has actually led to a lot of productivity improvements in enterprises. Even in point opportunities, where we have point opportunities to improve, if we can improve the breakdown, if we can improve unscheduled breakdown time reduction by 30%, that's a huge improvement in the overall plant operations. If we are able to improve the replenishment level in the warehouse by, say, 30%, we already saying that in outbound logistics, we'll have 2 more trucks going every day out rather than the current 5 trucks. And these are quantified productivity improvements which we can get. And the technology what we are talking is augmented reality, virtual reality, mixed reality, hands-free operations on TeamViewer platform, connecting it with your backend systems. These are not isolated systems. These are systems which are connected with your SAP systems, which are connected with your warehouse management systems, which are in front end connected to your smart readers, whether it is a QR code reader, whether it is a barcode reader or an RFID tag reader. And in the entire application landscape, as a OT application landscape, we fill in the last mile gap to ensure the right data is connected, the person takes the right action as per the guidance which system is giving him, and after all reports it properly, so that for future references a good knowledge organization can be created. And all this adds up to the productivity. Ashok.
Yeah. In fact, I can relate to our own cafe here very much with a lot of digital investments that has been made in cafe, right from creating a part geometry to assembling it digitally to getting the prototypes built, having the tractors built in the plant using advanced MES, and as I mentioned, digital bouquet, these tools gives us tremendous flexibility and productivity, and more importantly, ensures that customers get extremely high quality product, which really makes them happy. So it's up to us, how we can keep on going forward in this journey for all of us to see how these tools, these interventions, and these developments, whether it's in terms of hardware or whether in terms of software, analytics, all these things, how we can harness this more and more, that we continue to build world-class capabilities in our own country. And in my view, this is, again, like as I touched upon earlier, now the whole playing field is kind of reset, and it's becoming even more level playing field. So it's for us, countries like India, to see how we can harness these developments and come up with absolutely world-class products and challenge the rest of the world. So with that,
Ashok, just to add there, product development life cycle also has tremendously augmented because of the turnaround times improvement in the data analytics and how we are having the historic data. So that is one other productivity area. After sales support is another big productivity area. Because we are working with customers who are using our AR web service just for remote inspection or for remote maintenance, and those are live use cases where we see significant productivity improvement, like BMW or Ford Motor Company. If we are able to say, if the car comes in for a repair, and if we are able to reduce that time in the garage by 2 days, it's a huge improvement in the overall productivity. So we see practical life examples which are aiding to productivity, and we have solutions to support that. Ashok.
Thanks, Pranal. So with that, I would really like to thank the organizers for this opportunity, and over to you, organizers. Thank you so much, panelists also.
Thank you so much, everybody. And let me first express my heartfelt gratitude to all our wonderful panelists, starting with Dr. Devarajan, Mr. Govind Rajan, Mr. Brajesh Verma, Mr. Pranal Patel, and of course our super moderator, Mr. Ashok Muthuswamy. It has been an educative experience listening to all of you, and I'm sure all our attendees as well as the students who have been part of this session today, they will have a lot to take home with them. Thank you so much once again.
Thank you.